Assalamu alaikum everyone. So this is data integrity. Last time we studied data security and today we will study data integrity. So data stored on a computer should always be accurate, consistent and up to date. Two of the methods used to ensure that ensure data integrity are validation and verification. So integrity is sort of accuracy of data. All right. So let's start again with key terms. Key terms that we are going to use. The first one is data integrity. Data integrity means the accuracy, completeness, and consistency of the data. Now, how is my voice now? The completeness, accuracy, and consistency of data is data integrity. Second one is validation. Validation is the method used to ensure that the entered data is correct. Entered data is correct. Validations are written short software codes which are working in the background when we are entering data over the computer. So every single piece of data which is being entered is checked against those written codes and means it is computer codes which is basically used to validate the data. For example, range check, limit check, format check, these are all validation rules. And then we have got verification. Simply put, verification is checking of the data against the source. But you can say that method used to ensure data is correct by using double entry or visual checks. What does it mean? When we enter the data, we use a form. Let's say that someone has given form to two persons and they both are entering the data, and then computer is checking the data. If the data is entered by two people is the same, that's called double entry. Or someone asks you to re-enter the data, and do not confuse it with re-entry of password or re-entry of email, because if it is limited to one input field, उस सूरत में तो हम इसको कहेंगे कि वैलिडेशन है, लेकिन वेरिफिकेशन का मतलब है कंप्लीट फॉर्म. So verification is done for the whole of the data in a form, whereas validation is done over the fields, every single field. Okay. Then check digit. Check digit is a kind of validation which is basically an additional digit appended to the number to check if the number entered is error free. You see, by default we humans are not very much okay with numbers only. So if someone enters only numbers, so there are chances that after a few minutes, a few entries, data entry operator will start committing errors. Errors like swapping numbers, transposition, or skipping numbers, or entering a digit which was not there. So that will basically give rise to inaccurate data. So check digit is sort of a validation which is applied in the background for the data number only fields. It is basically a number, a digit, sorry, which is additional digit at the end of the number. So if the number is of 5 digits, एक और digit उसके साथ लगा दिया जाता है, 6 मिलके जो है वो एक number पूरा बन जाते हैं. So we will discuss that how the whole check digit thing works later. And then we have got modulo 11. Modulo 11 is a method used to calculate the check digit based on modulus division by 11. You know what is modulus division? Modulus division tells you the remainder. All right. So if you divide a number, whatever the remainder that we have, if we use that remainder for any of the purpose, in this case, we are going to use that modulo 11 output for check digit. All right. So that modulo 11 is a method for finding check digit. Then we have got checksum. Checksum is a method for verification. When one computer sends data to another computer, the one who is sending it is basically performing a mathematical calculation over the block of the data and finding its sum. Then that block of data along with that sum is sent over to the recipient. The recipient computer, what it does, it keeps that sums, re-perform the calculation over the block of data and finds its own sum. And then it checks the sum that it has found with the sum that is arrived. If they both are same, it means the data that is received is correct. So this is a method of verification. Then we have got parity check. Parity check is a method used by systems, machines during communication. It is used to check if data has been transferred correctly. That uses odd or even parity. Most of the examples that we use for parity check is for the data which is text. All right, so we will see that how parity check works and all. Then we have got parity bit. Parity bit is a bit, the last bit on the most significant side of any number. This is the most significant bit, you might say, which is set to make it okay for the parity to be transferred. So it is an extra bit found at the end of the byte over the most significant side that is set to 1 if the parity of the byte needs to be changed to agree with the sender receiver parity protocol. What are those parity protocols and all, we will see. Then we have got even parity and odd parity. Even and odd parity. So when we set parity, if the two computers which are recipient and sender, if they decide that they will use odd parity, then we make sure that before we send every byte has got the number of digits, which a number of bits which are ones are odd. If they are not odd, we make the leftmost bit 1 to make them odd, and if it is even parity, then we try to use that leftmost bit, which is the parity bit, to make them even. We will see, we'll look into it. So let's start. Data integrity. Then we have got data key terms. We have got data integrity, validation, verification, check digit, modulo 11, checksum, parity check, parity byte. We forgot parity byte. So parity byte, that is an additional byte sent when we are making use of block parity. All right, so in block parity, we perform vertical parity. We will look into it later. And then we have got ARQs. You can see that all of it we have already studied in O levels. And it is, let's say, a reminder of that at, let's say, thoda sa additional level. So ARQ is automatic repeat request that is used for verification of the data when data is being transferred from one device to another device. अच्छा, फिर हमारे पास आता है ARQs में एक वर्ड आता है acknowledgement. Acknowledgement is the acknowledgement of the receipt sent by the recipient to the sender. While the communication is happening, we will see that how it works. And then we have got another term attached to ARQ is timeout. So timeout is basically the time set between two devices for the receipt of acknowledgement. If the receiver does not send acknowledgement in the given time, the timeout occurs and the sender will resend the data. So validation. Validation and verification, these are two things which we are actually studying today, and they come under the umbrella of data integrity. So the accuracy, the integrity of the data can be compromised during the data entry and data transmission. All right, you might commit few errors while the data is being entered, or when the data is being transferred from one computer to another computer, there might be a few bits which are either gained, means they became one from zeros, and dropped, means they were ones initially and then now they have become zeros. Malicious attacks over the data, that might be hacking attacks or might be deliberate changing of the data at the site or whatever, or by the accidental loss of data. So data accuracy might be compromised. So validation first. Validation is a method of checking if the entered data is reasonably or within a given criteria, but it cannot check if the data is correct or accurate. For example, we might have a check for entering date, age. So let's say system, we have written a short code that accepts date, age between 15 and 20 years. अब जैसे कोई 16 साल का और मैं उसके लिए 19 साल लिख दूं, so instead of 16, 19 will be accepted because data is valid. But in verification, we will find out that the data that was entered is incorrect. So it means that valid data can still be non-verified data. सही है? So actual age was 16. Someone entered 19. 19 was accepted because that was the within range that was set by the field where we are entering the data. It is accepted. So जब सारा data enter हो जाएगा तो उसके बाद फिर when the form is printed out and when we will check, we will come to know that, oh, this data is incorrect. So validation are the checks which are programmatically written checks, and they will check every single data which is being entered if it is as per the rules set by the data entry program. So what are those few validation checks? The first one is type check. Type check. Check whether the non-numeric data has been input into the numeric field. It checks whether non-numeric or text data is entered, let's say, in a Boolean field, or if someone has entered text in date field, means it makes sure that जो data आप डाल रहे हैं वो उस field की type के मुताबिक हो. That is called type check. Range check. Range check का मतलब है कि जो हम data input करेंगे वो number है और उसकी एक range है. Checks whether data entered is between a lower and upper range. All right. Then we have got what? लिमिट चेक, लिमिट चेक का मतलब है कि रेंज में तो दोनों साइड्स होते हैं ना, लिमिट में एक साइड होती है, ठीक है। लेट्स से द मिनिमम एज फॉर ओ लेवल इज 13, so if you are less than 13 you cannot appear O level, but the maximum age is, there is no maximum age. Okay, so if there is no maximum age, ठीक है, ISBN is an example of check digit, yes. So similarly, if you go a gym and you see that it is written that maximum age of admission in this gym is 70 years, it means it is limit. Then we have got format check. So format check whether the data that is being entered is as per the agreed format. Like we have got a format for date DDMMYY, or we want an ID to be entered like digit digit, alpha alpha, digit, and then a special character, something like that. So when there is an agreed format, data must be entered as per that format. That's called format check. Then we have got length check. Length check means you have to count the number of characters in the entered data, and they must abide by the set rules. It checks whether the data that is entered, the number of characters in that particular field is as per the agreed length. Then we have got presence check. Presence check is basically the check to make sure the data field is not left empty. So the error that appears, you cannot leave this field blank, something like that. Presence check must be applied to those fields where you don't want your user to leave the field or the box empty. Then we have got existence check. Now existence check is if you have entered an ID, then system wants to make sure that that ID is already present in the database or the store of data. So if you have entered a wrong ID and that wrong ID is not found in the database, then existing checks will give an error. All right, so people confuse between existence and presence check. Presence check is you cannot leave this field blank, whereas existing check is whatever the data that you enter must be one of the data that are already saved in the database. Okay, only those IDs are requested which are already saved. If you have an ID which is not in the database, then get yourself registered, something like that. All right, so then consistency check. Consistency check whether the data in two or more fields comply with each other. For example, let's say someone has chosen title as Mr. and gender as female. So that would not comply. The consistency, this is called consistency error. Okay. Let's say someone has chosen age 17 and in studies they are choosing PhD. So nobody can do PhD in 17 years. So if the data in one field does not comply with the data in another field, that is said to be the consistency check. And then we have got uniqueness check. Uniqueness check means data in each field must be unique and that must not already been entered, that must have not been already entered in the same field ever before. Okay, this is uniqueness check is basically applied when we enter a new record. ठीक है क्या जो हमने database में किया था. So these are the validation checks. Then comes verification. So you get the idea that validation checks are those checks which are programmatically applied behind every data entry field. They only apply to one field, whereas verification applies to the whole collection of data in the record or the form or complete number of fields. Okay. Now verification. So what is verification? Verification is a way of preventing errors when the data is entered manually. It is a way for preventing errors when the data is entered manually using a keyboard, let's say. For example, a keyboard, or when the data is transferred from one computer to another computer. So let's say verification is applied to two types of the data, which is being entered manually or dusra in communications. There are two verification methods for manual data entry. One is double entry and the other one is visual check. In communication, it is parity. Check digit, say parity, and then we have got checksum. Okay, and I told you that parity checksum and ARQ, automatic repeat requests. Say it. Okay, so double entry means that you are entering data manually, and once you finish entering the data, you re-enter the complete data again, and computer checks it whether the two of the data that you entered were exactly the same or not. This does not apply to a single field double entry like please re-enter your password or re-enter your email or something like that. This applies to the whole data entry, to the whole form. And then visual check. Visual check means that you have entered the data, get a printout and place it side by side with the original form from where you have copied the data and match them, or uh, put the original form by your screen and check if the two are having the same data on it. Parity, let's study parity first. Let's study parity first. Okay. Okay, so let's say there are two computers. Let's study first in generalized way, then we will be specific later. There are two computers. They are sending data to each other. Let's say this computer one is the sender at the moment, and this is the receiver. Okay. So sender sends the data. There is a protocol in place which is called ARQ, automatic repeat request. There is already a time set. There is a time set for the reply. If the second machine does not reply within the time set, then timeout occurs. When second machine does not acknowledge during set time. If timeout occurs, then first machine resends the data. If acknowledgement arrives, then there are two possibilities. Number one, data received and it is correct. Data received and it is correct. Send more. Second possibility is data is received and it is corrupted. Send again. This whole protocol is called ARQ, automatic repeat request. Why do we call it automatic repeat request? Because one computer has sent data to another computer and they have 2 minutes in place, let's say. And during 2 minutes, if second computer does not reply, does not acknowledge, first computer will resend again and again and again. This is automatic repeat. But if acknowledgement arrives, then there are two possibilities. The data that is arrived is okay, send more, or it might be data that is arrived is corrupted, so please send again. So it means that receiver would have to check the data that is arrived. That is as parity check or checksum. So this sender over here, this sender actually prepares parity and checksum and then sends it over. So receiver will recheck it. Now what is parity? First of all, you need to understand that parity is mostly used with text. Parity is used with text. Why? Because text uses ASCII. ASCII is from 0 to 127. It means that it requires 2 to power 7 bits, which is 128 from 0 to 127. It means that one byte, if it has got 8 bits, will only be needing first 7 bits, 1, 2, 4, 8, 16, 32, 64. And this particular bit in every byte of the ASCII in the text will be used as parity bit. Now what will happen if the two machines would have set for the even parity? तो अगर फर्स्ट करें आपके पास A जा रहा है, A is 65, so 1, 2, 4, 8, 16, 32, 64, 128. Now this 128 is not used. Let's say if the two computers have set for even parity, it means that the number of ones in this particular ASCII code is already even. The system will use what? 0, because the number of ones is already even. Let's say if it is B is 66. So 1, 2, 4, 8, 16, 32, 64. So number of ones is already 2. It is even, so put 0 there. And then if it is C is 67. So 1, 2, 4, 8, 16, 32, 64. Now the number of ones is odd. 64, 65, 66, 67. So इस सूरत में हम क्या करेंगे? We will put 1 here to make it even. If it is odd, then sender will make it 1 because it is even, so 3 will be odd. Sender will make it 1 because it is already 2, then it will be odd as 3. And sender will keep it 0 because it is already odd. अब जब ये रिसीवर के पास पहुंचेगा तो रिसीवर जो है वो इसको फिर चेक करेगा कि as per the previously set protocol whether I am to receive even parity or odd. If it is even, then it will start counting the number of ones in it, and if it is already even, that is fine. चलो भाई acknowledgement भेजो कि और डेटा भेजो. लेकिन अगर नहीं है तो फिर ये सेंडर को दोबारा बोलता है कि भाई data is received but it is corrupted, so please reset. There are two weaknesses. There is a weakness with this single byte parity system. Single byte parity has weaknesses. For example, If 2 bits, sorry, are swapped, this 1 comes here and this 0 goes there. What will happen? The number of even bits will remain even and odd bits will remain odd. So the receiver would have no idea. If 2 bits are gain, what is gain? Gain is if a bit from 0 to 1, it is gain. If 1 bit which is 0 has become 1, it is gain. And if 1 bit is 1 and it has become during the transmission 0, then it is drop. Yeah. Okay, Dua, I got it. Okay. So, or thirdly, if 2 bits are dropped, in all these 3 cases, receiver would have no idea what has happened with the byte and it will accept it as the correct byte. All right. During the early years of the keyboard, when it was with a thick wire and all as a new device, this was a common thing that whatever the data that we are actually typing over the keyboard, when it is reaching to the computer, is imperfect. So parity was the basic saving action against incorrect data received. All right. So in order to overcome these weaknesses, what basically happens that instead of sending data byte by byte, what we do, we find vertical parity as well. So this is horizontal parity, byte parity, and then we find what? Vertical parity. So this is already even, this is even, this is odd, so we put 1 here to make it even. This is odd, so we put 1 here to make it even. Now, this is very important to understand. If it is all zeros, whether it is even parity or odd parity, the parity of every bit will remain 0. It really does not matter we are using even parity or odd parity. In both of the cases, if it is all zeros, then the parity bit will remain zeros. Now, this is called block parity. And this additional byte that was created because of the vertical parity is called parity byte. Sir, I have to leave early since I have to go somewhere at around 8:15. Please mark my attendance. I will watch the recording of the remaining lecture. Let's see. So this is block parity. Now, what are the advantages of block parity? Advantage of block parity is basically, as you see that when we send the data from one computer to another, if it is byte parity and the receiver identifies that the data is corrupted, during the acknowledgement session, receiver asks the sender to resend it. But if it is block parity and if there is an error, receiver finds that error, receiver will correct the data itself. Let's say during the transmission, this particular bit gained and it has become what? 1. Receiver would have no idea that what has happened. So receiver will check first the row. If it is correct, yes, it is correct. Then second row, if it is correct, no, it is incorrect. So it will mark it. Then it will check third row. If it is correct, yes, it is correct. And then it will start checking the final row. There might be error in the parity byte as well. Then it will check every column. Is it correct? Yes, it is correct. Is it correct? Yes, it is correct. Is it correct? It is correct. Is it correct? It is correct. Is it correct? No. So it is marking it. So system will mark it as well. Then it keeps checking. If it is correct, yes, it is correct. It is correct. It is correct. It is correct. So it has found one row and one column which are not even, rather they are odd. So receiver at the junction of these two markings will automatically be inverting the bit. So that bit which was 1, system will make it 0. And putting this 0, making this 0 will correct the whole scheme. So this is called block parity. So what is the advantage of block parity? The advantage of block parity is time saving and bandwidth saving. Why time saving? Because receiver will correct and identify the errors itself. Sender will not have to resend the data. When sender will not resend the data, both the time, as in when we resend the data, it takes time, and the bandwidth means when we resend the data, we send more data, so that also occupies bandwidth. So they both are saved, and receiver will correct the data itself. So this is called block parity. There might be questions. There are several questions in the past papers which actually give you the whole block of data and they want you to find the error in it. So, but they will tell you if it is even parity or odd parities, then you check every single row for correct parities and you mark where there is no correct parity, and then you will check every column for correct parity and mark the column where it is not correct parity. Once you mark it, at every intersection, you will change the bit. That changing of bit at the intersection of a row and column will correct the whole block of data. That is how it happens, and there is always a question of 3 marks, how you identified the error. So you will say that I checked all the rows, then I checked all the columns, and I marked wrong row and wrong column. And at their intersection, I flipped the byte myself. That is how it works. Then comes checksum. So let's take this example of ABC once again. Sender has to send A, B, and C. Hasim Mustafa, sir, how did you create the additional byte? How did I create the additional byte? I found parity for every column. I found parity for every column. That parity for all the columns created the additional byte. Does this type of block parity question comes in AS level? Yes, Jazir, exactly. So how was the additional byte form? ऐसे ऐसे हम चेक करते चले गए तो ये वाला बाइट निकल के आ गया बेटे, ठीक है. अब फिर ये पूरा ब्लॉक पैरिटी का बाइट बन गया. ये एडिशनल बाइट है. इस एडिशनल बाइट को हम कहते हैं पैरिटी बाइट. ऑलराइट, देन कम्स चेकसम. चेकसम में क्या हुआ, ये आपके पास 65 है, ये 66 है, ये 67 है. अब इसमें हम पैरिटी की बात नहीं कर रहे, ठीक है. पैरिटी एक्सक्लूडिंग पैरिटी हम बात कर रहे हैं. सो दिस इज 1 2 4 8 16 32 64 128. This is 1 2 4 8 16 32 64 128. This is 1 2 4 8 16 32 64 128. This is the block of data which we want to send over to another computer via sender or transmitter. So what system does, system will add all these three rows of bits. Okay, so this has become 198. Okay, 198. So that would be 198. Okay, so this is 198. This whole byte will be sent from one computer to the next. The receiver will keep this byte separate and reperforms the sum operation, finds its own sum and checks it with the sum that is received. And checks it with the sum that is received. So both sender and receiver would have found their own sum. If there was any error during the data transmission, the sum at the receiver's end will get changed and receiver would know that there was an error during the data transfer and data is corrupted. So it will ask the sender to resend it. Okay. Now, there might be several questions like, sir, maybe different combinations will produce the same number and all. So this is one of the most simplistic form of teaching checksum. Checksum is quite complex. It's not like what we have done now. Okay. So there is one thing that you have to basically keep in mind. This sum, if it is less than or equal to 255, then it is accommodated in 8 bits. If this sum goes beyond that, for example, if it is Z, which is 90, Y, which is 89, and X, which is 88, will not give you any number which is within 255 range. So that number will be increased. In that case, तो checksum में कुछ additional चीजें चलेंगी, ठीक है? अब सबसे पहले क्या चलेगा? Let's say हमारे पास जो number है, वो आ गया, ये जो total आ गया, total, ये हमारे पास क्या आ गया? ये total हमारे पास आ गया 267. So this is basically greater than 255. So this is 267. We will call it X. So X is now 267. हम क्या करेंगे? हम सबसे पहले divide करेंगे the sum X of the bytes by 256. So we will divide it by 256. Okay, so divide by 256. ये हमारे पास जो भी नंबर बनेगा, we will round that down to the nearest whole number, round down. So ये हमारे पास बन रहा है 1.043. अब हम इसको राउंड डाउन करेंगे और इसको असाइन कर देंगे y को, which is 1. ठीक है? अब फिर हम क्या करेंगे? हम एक z बनाएंगे which is y into 256. Z, it is y into 256. ठीक है? अब हमें डिफरेंस निकालना है. Y is equal to 2, y into 256 remains 256. अब हमने डिफरेंस निकालना है. डिफरेंस क्या होगा? डिफरेंस होगा x minus z. तो वो कितना बन गया? X is what? 267. Z is what? 256. 267 minus 256. That is 11. Now this 11 is the checksum. Now this 11 will be used as the checksum. So असजद हमारी पूरी कहानी इस चीज के गिर्द घूम रही है कि हम डेटा फ्रॉम वन कंप्यूटर टू अनदर कंप्यूटर भेज रहे हैं. If the data while it is being transferred got corrupted, we should have ways to find it out, which is verification. So the use of parity byte is to make sure that the data that is transferred in block parity had no corruption while it was being transferred. That's it. तो जब हम block parity लेते हैं तो हमारे पास additional parity byte तो आ ही जाता है. ठीक है? So why do we divide by 256? This is standard because dividing by 256 will give you a remainder from 0 to 255. That is why we divide by 256. And then we round down towards the nearest whole number. Okay? So if checksum is, or let's call it if sum is within 2 to power 8 range, then it is the checksum. If the sum is greater than 255 or 2 to power 8 range, which is 256 from 0 to 255, then we divide sum by 256. Round down the answer to the nearest whole number. Then we multiply by 256. Subtract that from X. Result is checksum. It will always be within 255 range because we use the factor of 256. All right. So that is how the checksum is found. So change in SQ value can also give the same sum. Then what? Hasib, I told you when I started off with this is one of the most lame method we teacher used to teach. It is not that simple. There will be complex methods. Okay. So I know that different combination will produce the same result in all. So just leave it. You know what checksum is, how it is being used for finding data corruption. As far as the method is concerned, the method is simplistic. Just to make you understand about it, we are not studying communications. Rather, we are studying the topics that we use while the communications happen. Okay. Now, so parity is done, checksum is done. Let's get back to the first thing. So I did explain Verification happens for two things: when we manually enter the data, and when communications happen. When we manually enter the data, we take care of the data correctness for verification using double entry and visual check, and when communications happen, we use Parity Checksum and ARQ protocol. Now let's solve few past paper questions for this particular chapter. Okay, so कुछ क्वेश्चंस पास पेपर्स के सॉल्व करते हैं ताकि आप लोगों के लिए ये डेटा इंटेग्रिटी और डेटा प्राइवेसी जो है वो रिवाइज हो जाए. चलें, let's solve these questions in backward manners, latest to oldest. Okay, now this is May June 18 P11 Okay, the following binary number is transmitted using parity, even parity. Okay, and missing parity bit. अब जो हमारे पास even parity होगी, because it already has 1 2 3 4 even bits, so the parity will be 0. Now in the following parity, the first column contains the parity bits and the last row contains the parity byte. First column and last rows. A device transmits the data using even parity. Okay, explain how you identified the error. We have to find the error. So 1 2 3 4 5 6, it is correct. 1 2 3 4, it is correct. 1 2 3 4, it is correct. 1 2 3 4 5 6 7, so this is incorrect. All right, now 1 2 3 1 2 3 4 5 6, it is correct. Now we have to find in columns. 1 2 3 4 correct, 1 2 3 4 correct, 1 2 3 incorrect. Okay, 1 2 3 4 correct, 1 2 correct, 1 2 correct, 1 2 3 4 correct, 1 2 3 4 correct. So it means at the intersection this particular bit got corrupted while the data was being transferred. Explain how you identified your answer. You would say हमने जो है पहले लाइनें चेक करी, फिर कॉलम चेक किए, तो जिन लाइनों में ऑड था और जिस कॉलम में ऑड था उसको हमने मार्क किया, then we circled. The data received can contain errors that are not detected using parity bits. अभी मैंने आपको बताया, explain how this happens. When two bits are swapped, two bits are gained or two bits are dropped, we cannot identify it. Okay, parity is not the only method to verify the data has been sent correctly. Remember verification. Name and describe another method. That would be what? Checksum. Now, a small company produces scientific magazines. Okay, a small company produces scientific magazines. The owner buys some new desktop computers. The computers are used to store thousands of color images, diagrams, and photographs. All the computers have internet access. Part C says employees using the new computer receive training. At the end of the training, each employee completes a series of questions. 3 answers given by employee are shown below. Explain why each answer is incorrect. Oh my God. Data validation is used to. Let's just take this one only. Data validation is used to make sure that the data keyed in are the same as the original data supplied. This is wrong. All right. The data validation is used to make sure that the data keyed in are the same as the original data supplied. This is the explanation of data verification. Data validation ensures that the data is sensible within the given criteria as per the rules set. Okay? So you have to tell that. Okay. So the table shows bit patterns for 12 bytes. Even parity was used, and the first bit is the parity bit. Okay, there is one error. So you find one error yourself. Explain your answer. This is the same. Part B. Part B says verification and validation can be applied during the data entry. Validation and verification can be applied during the data entry. Describe what is meant by these terms. Each method explain why it is needed. Okay, this is October-November 2015 P12. Part B. October-November 2015 P12 Part B. So what is verification? Verification is required to make sure that the data that has reached on the destination side is consistent, it is as it was sent. And in verification, mostly the comparisons of the data which are sent and received are used. If the data is manually entered, then double entry and what do we call it? Double entry and visual check is used. If the data is being transferred using communications, then in that case, we will use parity and checksum. Whereas validations are basically the checks that when the data is being entered in the table, make sure that data matches the required criteria, or it is within the reasonable range that is accepted. These are the automatic checks over the computer, and you would have to tell few of the examples like range check, limit check, type check, format check, etc. And you would have to tell that the valid data can still be incorrect, as the validation only applies to the range of the data items which are being entered, and it cannot make sure that the data that was entered is correct. And then you can give the example of age, that if, let's say, if the age between 15 and 20 is acceptable, someone's age is 16 and yet 19 is entered, 19 will be accepted because it is valid, but it is incorrect and non-verified. All right. So it says that give a brief description of each of the following terms. We can do that. Data are to be transferred between two devices. Parity checks are carried out. Explain what is meant by parity check. So this is basically October, November, P11, P13. So what are parity checks? So parity checks are basically uh, parities. It's a check for data verification. It can be even and odd. Parity check uses the numbers of ones in the binary system. If there is even numbers of one and if the check is even, then in the parity bit, which is on the leftmost side, an additional bit or the 8th bit is made 1. If it is even parity, then it is made 0. If it is not, then it is made 1. When the byte is sent one by one, every byte's parity is checked at the sender's end, and if the if the receiver finds that the bits are not as per the set parity type, then it acknowledges, but acknowledges with the corruption of the data so that the data could be reset. So you would have to actually form the whole thing. These are 4 marks. A satellite television receiver has a number of channels. A user keys in choice of the channel using the handset. The handset and the receiver are each controlled by a microprocessor. When a user keys in 34, this value is stored in 8-bit register as shown below. The 8th bit is the parity bit. The user keys in 47 shows the value stored in 8-bit register. So you will have to actually show what is 47 and then you will be putting the 8th bit. Okay. So A, this is even parity or what parity? 8th bit is parity. 47 is 1, 2, 4, 8, 16, 32, 64. So 32 and 8, 40, 44, 45, 46, 47. Show the value stored in. Calculate which channel has been selected if the 8-bit register contains this. Which type of parity is this? Do they say anything? No. So leave the parity bit. Calculate which channel is this. 1, 2, 4, 8, 16, 32, 64. So 64 and 8 is 72, 73, 74, 75. So 75 is motoring and leisure. Okay, what else? Describe what could happen if the handset transferred the following selection. What could happen? 1, 2, 4, 8, 16. This is 20, 1, 2, 4, 8, 16, 32, 64. So this is 64, 74, 84. 84, we don't have any channel for 84. So we will say that nothing will happen. The channel will not be changed as 84 does not exist. Then it says that even parity is used when the handset transfers data to the receiver. Give the parity bit that is required in the 8-bit register of the part C. Let's say if it is even parity, so 1, 2, 3, हम यहाँ पे even लगा देंगे for even parity. यहाँ पे आप लिख दीजिएगा for even parity. Since we have not complete questions, we cannot say what was the actual. We just kept the parts which belong to the topic. अब आगे पीछे उसमें क्या होगा हमें नहीं पता. अच्छा जी. 3 of the items above undergo a validation check. Identify the 3 items that can be validated. Give suitable validation checks for it. This is format check, credit card number 16-digit length check, telephone number type check, postal address. That is fine. Presence check. Yes, presence check. We cannot leave this field blank. This is presence check. Okay. Now, email address. Email address might be format check. Acha, name the method where data are entered twice for checking purposes. Double entry. Give a reason for your choice. Name the item which will undergo this method. One item. Email address, telephone number, credit card number. You can put any, and then you will tell them कि भाई this is the reason कि हमें इसमें accuracy चाहिए. Identify the byte that contains incorrect bit. Identify the bit position that can explain why this parity, why using this parity system that there is no need for incorrect byte by byte transmission because it is sent in the form of block. This is all simple. In addition to parity bit check on the byte, a parity block check is also carried out. A computer transmits 4 bytes by a parity bit. One of the 4 bytes has an error. Write down the corrected byte. Explain the computer system. This is all. This is all revision of everything. A vending machine dispenses drinks and has number of drinks options. The vending machine is controlled by the microprocessor. If the customer keys in 23, they will receive a cup of milk, coffee with milk and sugar. This is a question like O levels. Yeah. A selected code is stored in 7 bits registered. So 23 is stored like this: 1, 2, 4, 8, 16. 16, 20, 21, 23. If an invalid key is keyed, an error message is displayed. This system uses even parity and extra 8 bit is used. So this is 1, 2, 3, 4. We have got this even parity. Okay, now what is this? A format check is a type of validation for an input string. A format check can be implemented using an input mask. An input mask contains a string of characters which indicate the type of the character allowed in each character. A software application uses the following codes for specifying an input mask. Okay, the following input mask is used on each of the data items in the table below. Okay, which one of the following data item would pass and fail? So TT9, what is T? A letter must be present. A letter must be present. A letter may be present. Okay, may be present. So TT, letter present, letter present, letter present, letter present, letter present, letter not present. Letter present, not present, letter not present. ये तो fail होगा. Now the other one is 9. 900. What is 0? A digit must be present. 9, a digit may be present. So there might be 2 or 3 digits. So 3 digits pass, 2 digits pass. Okay. Now then we have got TT. A letter must be present. So fail and pass. This is the only number that could pass it. You see, आपको ये मतलब मैं कोई जादूगर नहीं हूँ. ये कैसा क्वेश्चन आएगा हमें नहीं पता. उन्होंने हमें ये सारी फॉर्मेट बता दी. अब हमें खुद ही जो है ना उस वक्त अंदाजा लगाना होगा. मैं तो आपको सिर्फ गाइड कर सकता हूँ. ऐसे क्वेश्चन जो हैं वो तो कैसा आ जाएगा, क्या हो जाएगा, Data security and privacy are major problems in using wide area network. Describe method that can be used to minimize these problems. Data security and privacy. There might be several things: passwords, encryptions, firewalls, fiber optics, microwave links can be used to keep it secure. All right, monitor the system access, physical access. There might be several things. Data security and privacy are major problems in using wide area networks. Describe methods that can be used to minimize these problems. Okay, backups. Wide area network is no more the part of the syllabus, so let's follow the questions backward. A small company, a small company produces scientific magazines. The owner buys some. So let's see part C. Employees using the new computer receiving training. At the end of the training, each employee completes a series of the questions. 3 questions are given by the employee are as follows. Explain why each is incorrect. Encryption prevents hackers breaking into the computer system. So basically, hackers can still access the data and corrupt it. All right, because encryption does not prevent the access. Encryption can only encrypt the data, make the data in the form which cannot be understood by the hackers, but hacker can still reach the data and corrupt it or delete it. All right, the use of passwords will always prevent unauthorized access to the data stored on the computers. A password does not prevent unauthorized access, it makes it more difficult. Password can be guessed if it is weak. Simple. All right. So, May June 16 P13. A bank holds personal data about its customer and their financial data. Describe the difference between security and integrity. Security is keeping the data safe. Integrity is making sure that the data is correct and valid and consistent. Security is the prevention of data loss. Integrity ensures that the data is received the same as the data that was sent. Uh, an example of security is username, passwords, encryption, whereas data integrity is parity check, double entry, whatever, visual check. Part B. Describe 3 security measures that the bank could implement to protect its electronic data. Installing a firewall to stop unauthorized access from the hackers. Use authentication methods such as passwords and usernames. Passwords should be strong. Encrypt the data so that if the data is accessed, it will be meaningless. Mind it, whatever the reason that you give, you would have to put one line to describe that reason as well. Okay. Now, describe 2 types, differences between data integrity and security. We just discussed. Data integrity is required at the input stage and also during the transfer of the data. State 2 ways of maintaining data integrity at the input stage: visual check and double entry. State 2 ways of maintaining data integrity while the data is being transferred. That is basically verification, parity, checksum. Give definition. May June 2015. Give the definition of the term firewall and authentication. So firewall sits between the computer and the outside external network or internal network, LAN and outside network. It can be a software or hardware or combination of both. Software firewall can make precise decisions as we set the pre-decided rules, and as per those rules, every single packet which is coming in and going out will be checked by the firewall. It can help block the hacking attacks. Whereas authentication is the process of determining whether something is who what they are claiming. Someone is who they are claiming to be, uh, they because and they must pass through the passwords, because passwords are known to only those people who owns the ID, second level authentication, as we all know of it. And that's about it. I think you don't have to put anything extra. So this is it. This is about the whole chapter 6. Let's review chapter 6 if something is remaining, so that we could go ahead and study ethics in next class. Hold on. Okay. Now, chapter 6. Explain the difference between the terms security, privacy, and data integrity. Security, privacy, and data integrity. Security is when you want to secure the data. Privacy when you don't want anyone to access your data. Integrity when you want data when it is being entered or transmitted, and you want it to be consistent. Show appreciation of the need for the both security and security of data and security of the computer system. Okay. Describe security measures designed to protect computer system, ranging from the standalone PCs to network of the network computers. We have discussed so many things: passwords, user accounts, authentication, digital signature. I just explained it that it is a method of encryption and decryption, but the detail of the digital certificate signature we will discuss in A2. Firewall, antivirus software, it is spyware, encryption. Show understanding of the threats to the computer, like spyware, viruses, hackers, phishing, farming. We have discussed it in detail. Describe the method that can be used to restrict the those threats. Okay, we discuss all those. Describe the security measure designed to protect the security of the data, like encryption, access rights. We discussed everything. As far as data integrity is concerned, describe how the data validation and verification help protect the data integrity. We discussed about it. Describe the use of methods of data validation, like range check, format check, length check, presence check, existence check. What is the difference between presence and existence? Presence check is you cannot leave this field blank, and existent, the ID that is being entered must be one of the IDs which we have already in our databases. So limit check, check digit. Okay, during data entry, describe the use of method of data verification during the data entry and data transfer. Data verification is double visual check, double entry. Data transfer including parity check, byte and block parity both, and checksum. So we have covered pretty much everything that was given in the syllabus with past paper question, and I hope that you would have made sense of it. If there are any questions, please do ask those questions in your respective WhatsApp.